All right, so 23, we've got 4,500 deposited into account paying 6% interest. What is the amount of the account in the account at the end of 5 years if the interest is compounded monthly? All right, so this is that weird middle ground between you're not going to use just the basic form, just ab to the x, and just be done real quick, but you're also not going to use the continuous form. That's also pretty quick. You're going to kind of be in this middle ground where we're compounding specifically monthly. That means that we're going to compound 12 times in a year. So what's going to happen is you're going to get 6% total in the year, but you're going to have to divide that by 12 months. So you're only getting 1/12 of that percent each month for 12 months, and it'll add up to 6%, and that actually ends up being a little better for you than if you just compounded one time at the end of the year. So when people compound, say, monthly or another unit, what they're doing is they're compounding more often, and it's going to give you slightly more money than if you just did it at the end of the year all at the same time. So it's actually for your benefit when people do things like compounding monthly instead of just at the end of the year, but it is a little bit more complicated to write the formula. Not a lot, but a little. So you just have to think about what's happening. So if your general form is ab to the x power, your starting amount is still 4,500. That part doesn't change. What does change is your interest you're gaining per year. So you're not gaining just 1.06. What's going to happen is you're going to have 1 plus 0.06, with 1.06, but that 0.06 is being divided by 12. Now you could go ahead and come in, type 0.06 divided by 12, and you could write 1.005 instead, but typically, just to make it easier, you don't actually do the calculation. You just say 1 plus 0.06 divided by 12, whatever that's going to end up being. So if we're compounding monthly, we divide by 12. If you were compounding daily, you would divide by 365, because there's 365 days in a year. If you were compounding quarterly, that means 4 times a year. So whatever number, or however many times you would do it in a year, that's the number that you're going to divide by, because that's what your interest rate is being divided by each month in this case. And then the other difference comes in with x. You don't just write to the x power, because that would mean that you are going to know how much you're going to make at the end of each month. So you think, well, how many times would I compound in a single year? Well, you would compound 12 times in a year because we're doing monthly. So we would write up here raised to the 12x power. That way, when x is 1, 12 payments would be 1 full year. If x is 2, 12 times 2, 24 payments would be 2 full years. So by writing the formula like this, we're still finding out how many years, or how much money we'll have after a certain amount of years. Even though we're compounding monthly, this is going to provide us with an amount after a certain amount of years. So if we were to put that into the calculator, which is a little bit more work, 4,500 times 1 plus, I can use my alpha y equals feature to make it a little simpler to type in the calculator. So 4,500 times 1 plus 0.06 divided by 12 raised to the 12x power. So if I look at my table, I still started at 4,500. After 1 year, I would have $4,777.55. I'm looking for after 5 years. So after 5 years, I would have $6,069.83 if I rounded. Okay, so 2 minor changes. When you're compounding monthly, for example, there's 12 months in a year, it's going to divide your percentage by 12, and it's going to multiply the number of payments you get every year. So instead of you getting just 1 payment per year and just writing x, you're getting 12 payments per year, so you're writing 12x. So those are the 2 minor adjustments. You have to divide by the percent, and you have to multiply by the years, because there's 12 payments in each year.